Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to be going over another rate law problem. So let's get into this. So for this problem, the following mechanism has been proposed for the reaction of chlorine and chloroform. So here you have in the first step, chlorine gas reacting to form two chlorine atoms in the gaseous form, so it's split apart into two atoms. And then you have one of those gaseous atoms of chlorine reacting with chloroform to form HCl gas and this carbon trichloride gas. And then the carbon trichloride gas then reacts in step 3 with another one of those chlorine gaseous atoms and forms carbon tetrachloride. And so we're given some information about the K values. So let's label these K values here. So this is going to be K1. This one's going to be K minus 1 for the reverse. This one's K2. And this one is K3. And so the information we're given is that, so K1 is 5.0 times 10 to the third. And K minus 1 is 3.0 times 10 to the fifth. And K2 is 7.2 times 10 to the negative 2. And K3 is 4.5 times 10 to the negative 5. And so they ask us, derive the rate law and magnitude and units of K for the overall reaction. Okay, so let's start with the overall reaction. We need to figure out the overall reaction. So we're going to have to add these together to get the overall reaction. So let's put a line here. Okay. And so we're going to add these together. I'll write the overall reaction here in this space. So let's cross some things out. Let me use a different marker. So I have chlorine 2 here. If I have chlorine 2 as a product, I can cancel that out, but you'll notice I don't have any chlorine 2 as a product, so that stays. You'll notice here I have 2 Cl gas. I have single gaseous atoms of chlorine. I have 2 of them. And you'll notice I have one on this side, and I have another one on that one. So these two can cancel out with these two. So let's go ahead and do that. So these will cancel out. And that will cancel out that one and that one. Okay. So far, so good. I have CHCl3 gaseous on this side. And I don't have CHCl3 on that side. So that's chloroform. So chloroform will stay. Here I have HCl gas on the product side. On the reactant side, I don't have HCl gas, so that'll stay. Here I have carbon trichloride, CCl3 gas on this side as a product. On the reactant side, I have it over here once, so that'll cancel out. So I have that will cancel out there. And I have CCl4 as a product, and that's not going to cancel out anywhere here. So now I have the overall reaction. So let's write that down. So we have Cl2 gas plus the chloroform, CHCl3 gas, and then that's going to go to HCl gas plus CCl4 gas. And we'll call the K value here the rate constant KO for that of the overall reaction. Okay, so now that we have our overall reaction from these, now we can start to figure out what the rate law is for the overall reaction. And so when we look at the K values here, that's going to be really helpful because we need to figure out what the rate determining step is in the mechanism. So here's the mechanism that's proposed. Well, what's the rate limiting step? And that is going to be the slowest step. And that's going to be identified by the rate constant that's the smallest. The smallest rate constant identifies the slowest step. And so right away you look at here, so you have 5.0 times 10 to the third, that's a large number. 3.0 times 10 to the fifth, that's an even larger number. 7.2 times 10 to the negative 2, that's a really small number. And then we have 4.5 times 10 to the 5, that's going to be a large number. So K2 is the smallest rate constant that's associated with step 2. So therefore, step 2 is our slowest step. So that's going to determine the rate law of the overall reaction. So we need to start by writing out the rate law for the second step. So the second step rate law is going to be determined by the reactants. Even though they're crossed out, for the rate law we need to include them, right? We only crossed them out because we needed to get the overall reaction. But when we're considering the rate laws for individual elementary steps in the mechanism, then we have to, include everything. So here are the two reactants for step 2. So if we write the rate law for that, so the rate law, okay, is going to be the rate of step 2 is equal to the concentration of Cl gas. And notice that the coefficient is 1, so the power is 1 there. And that's going to be multiplied by the other reactant, CHCl3, that's chloroform. So CHCl3. Oops, you know what I forgot? I forgot the K value. We need our K. So that's going to be equal to K sub 2. Sorry about that. So K sub 2, that's the K value here. So the rate law is going to be the rate of step 2 times the K value, the rate constant of step 2, times the concentration of chlorine atoms, times the concentration of chloroform. Okay, now we have our rate law here. So we got to pay attention to K here. Notice that we have Cl. Now Cl, if we go back here, is an intermediate. So Cl is an intermediate here and here. So we have two Cl's here. We have Cl and Cl here. We can't have intermediates in our rate law expression, right? So we cannot have that. So notice CH3Cl3 or CHCl3 is in the overall reaction, so that stays, but Cl is not. We have Cl2 but not Cl. So we need to replace Cl, and we got to substitute that to get rid of it and have something that we can are allowed to have in our rate law expression. And so we're going to go here to our equilibrium. So since this is really fast, so the K1 and K negative 1, those are really fast. So that means that this reaches equilibrium pretty quickly compared to the rate determining step. So we can know that the rate of the forward reaction is going to be equal to the rate of the reverse reaction. So we could use that to our advantage to figure out what we can substitute Cl with. So let's go ahead and write that down. So we have, let's start with the rate of forward reaction of the step 1 forward reaction is equal to the rate of the reverse reaction of step 1. So minus 1 for the reverse. So we know that to be true. So let's write down what the rate laws for each of those, what each of those rates are, or those reactions. So the forward reactions, so if I write the rate law for the forward reaction, let me write it here. So rate 1 is going to be equal to K1 times what? The concentration of the reactant, which is Cl2. So we're going to write Cl2 here. Okay, so that's the rate of the forward reaction. That's the rate law for the forward reaction. And the rate law for the reverse reaction is the same this way. So we write the reverse reaction. So the rate minus 1 is going to be equal to K to the negative 1, or negative 1 there, times the concentration of its reactant. So since we're moving this way, Cl gas is the reactant going in the reverse direction. So that's going to be Cl, concentration of Cl. But we have a 2 here coefficient, so that means we're going to have a square here. Okay, so now that we have the rate laws for the forward and reverse reaction for step 1, and we know that they're equal rates, then if these are equal, then these are equal. These two are equal, right? So these are equal to each other. This is equal to this. This is equal to this. So if these two are equal to each other, then these two must be equal to each other by logic, right? So then we're going to then replace rates 1 and negative 1 with these here. So that's going to be K1 times Cl2, the concentration of Cl2 is going to be equal to K minus 1, or negative 1, times the concentration of Cl raised to the second power. So now that we have these two equal together, now we can solve for the Cl concentration, the concentration of Cl. We want to substitute this. So if we solve this for the Cl, then we'll have something we can substitute. So let's go ahead and do that. So let me go ahead and find some space. Let me go ahead and erase this. We don't need this anymore. So I'll go ahead and solve. So here I need Cl by itself. So I'm going to divide both sides by K negative 1. Right? So then I'm going to end up with Cl squared. The concentration of Cl squared is equal to, I have K1 over K negative 1, right? Oops. Right over here. So I got that. So these are going to cancel out. So I got K1 over K minus 1 times the concentration of Cl2. So times concentration of Cl2, like so. Okay, I'm almost done. I have that squared there, so I have to get rid of the squared because here there's no square. So I got to square root each side. So if I square root that side, I get concentration of Cl. Okay, because the square root undoes the square, and then I got to square root this side here. So then what I end up with is I get the square root of K1 over K minus 1, right? Times the square root of the concentration, let me write that better, times concentration of Cl2 square root of. Okay, so now I have this is equal to this, so now I can take this and substitute it in for Cl for my rate law here. Okay, my overall rate law. Okay, so here I'm going to go ahead and erase this here. We don't need that anymore, so hopefully you have that down. Okay, so now I can take this here and substitute in for Cl, the concentration of Cl. So then I'm going to get the rate 2 is equal to K2, but it's going to be now K2 times this. So it's going to be K2 times, and square root is the same as power of 1/2. So I can do the power of 1/2 here. Or I could just do square root. So maybe I'll do square root. So it'll be a square root of k1 over the square root of k, oops, let me write a better k, sorry about that. I might be reminding you of the television Monk, right? If you don't know what the television show Monk is, great show, look it up, you'll know what I'm referring to. Okay, so then this is going to be the square root of k minus 1. Okay, so I got that set up here. So that's added to that. And now instead of CL, I'm going to have the square root of CL2. So then I'm going to have the square root of the concentration of Cl2 times, and then I got the concentration of chloroform. So times the concentration of CHCl3. Okay, so now I have the overall rate law here. So let me just box that up so it's clear what we're looking at. Okay, so now we got that. So I'm going to go ahead and erase the rest of this since we don't need it anymore to give us some more space. Okay, I'm going to leave the overall reaction. Okay, so we don't need this anymore. Okay, so here's now the overall reaction for, or I should say the rate law for the overall reaction. Okay, now let's go back to the questions. Derive the rate law and magnitude. Okay, so we got the rate law. So let's clean this up a little bit. So this here is all together as the rate constant for the overall reaction. So let's go ahead and write that over here. So we have K, we'll call the K for the rate constant for the overall reaction will be KO. So that will be O for overall. And that's going to be equal to these rate constants here. So we have K2 multiplied by the square root of K1 divided by the square root of K minus 1. Okay, so we got that. So when we clean this up, basically what this is going to look like then now is we replace this here will be KO. So the rate of the overall reaction, so instead of 2, because remember we base all this on 2, but we don't have, this isn't 2 anymore, this is the overall reaction. So the rate of the overall reaction is equal to KO multiplied by what? The square root of chlorine, so the concentration of chlorine, Cl2. Instead of the square root, we can write that as a 1/2 power because that's the same as square root. We're just putting in the power form, exponential form. So square root is the same as raised to the power of 1/2. So we'll just put a 1/2 there. Okay. Oops, I forgot the other closed brackets there. And then we're going to multiply that by CH, the concentration of CHCl3. Okay, so then now we have the form of our overall reaction. That's good. So now that we have derived the rate law, so we've done that. Check, check, drive the rate law. Now what about the magnitude and units? Units, that's going to be important. Okay, so let's take some time to do this. Okay, so I'm going to go ahead and maybe I'll keep that. So, units. Okay, so we have to go back to the rate laws here. Okay, so, yeah, let me go ahead and I'll write it down here. So remember, we said that the rate law Okay, so we have the rate law of the forward reaction here. So remember, that's rate 1 equal to K1 times concentration of Cl2. Okay? And then also we have the reverse reaction. So we have to figure out what the values are or what the units are. We have the values here. We need to figure out what the units are now, right? So the units are based on the rate law. We can figure out the units from the rate laws, and I'll show you in just a moment. So let's write down the rate laws first. So we have rate law, let's say rate minus 1, that's the reverse here, we're going reverse. Remember, that's equal to K minus 1 times the concentration of Cl, right? Cl raised to the second power. Okay, so here we have K1, so this is rate law. So how do we figure out what the units are for the rate law, the rate constant here? Well, rates, we just go with the rate, right? So rate is defined as, like, so how fast are you moving, right? You're driving down the highway, it's a certain distance per certain time, right? So miles per hour or kilometers per hour or meters per second, right? It's the same with the rates of reactions, but here it's molarity per second, right? So how fast a rate is going is measured in molars per second or molarity per second. So we can at least know that, right? So the rate 1 here is going to be molars over seconds. Molars over seconds, right? Well, concentration is measured in molarity, so that's going to be molar. So this is going to be measured in molar, right? So what does K1 have to be if we multiply it by molar to get molar over seconds? That's right, you guessed it. So per seconds, right? So 1 over seconds. So K1 would have to be 1 over seconds, right? You see that? So now if I multiply molar times 1 over seconds, I get molar over seconds. So I figured out what the units for K1 are. Okay, I can now do the same thing for K minus 1, the reverse reaction. So again, rate is going to be molar over seconds. Here, the molarity it's squared, so I have the concentration of Cl squared. So if concentration is molar, then that's molar squared. It's molar to the second power. So that's going to be m squared. So then what does K minus 1 have to be in order to get molar over seconds? So here I have molar squared. I just want molar per seconds. So in this case, K1 has to be 1 over molar seconds, right? So 1 over molar seconds, right? So the molar here will cancel out with one of those molars, leaving me 1 left. And so then I get 1 molar over seconds. So these are the units for K minus 1. Okay, so I've got the units for K minus 1, K1, what about K2? So K2, we'll go back to K2. So that's the rate law for the forward reaction here for K2. Here's our K2. So let's write that. So we got K, the rate of reaction 2 in the forward direction is equal to K2 multiplied by what? We have the concentration of Cl times the concentration of chloroform, CHCl3. Okay, so we do the same thing. The rate is measured in molar over seconds, so we're going to have molar over seconds. We have concentration of Cl, so that's going to be molar. we have the concentration of CHCl3, so that's going to be molar 2. And we have molar times molar, and we want molar over seconds. So what does K2 have to be? So again, we need one of the molars to cancel out on this side. Oops, excuse me. Sorry about that. So we want one of the molars to cancel out here. So we're going to need 1 over molar, right? So the molar here will cancel out one of those, leaving one left. And we need seconds. We need seconds, so we need molar seconds. So again, we have 1 over molar seconds. So now that we have the units for all the K values, K2, K1, and K minus 1, now we can figure out the units for KO by plugging them in, right? Okay, so now that we have the units here, so let's write the units over here. So K1, this has units, what did we say? K1 was 1 over seconds, so we'll put 1 over seconds there. Okay, K minus 1, what was K minus 1? K minus 1 was 1 over molar seconds, so that's going to be 1 over molar seconds there. And then for 2, we have 1 over molar seconds again. So 1 over molar seconds. We don't need 3 because K3 is not in our KO expression. Okay, we didn't need it. Okay, so now that we have these, we can go ahead and erase this. We don't need this. Let's give ourselves some room so we can do our calculation. Okay, we don't need this anymore. That served its purpose. Okay, so now all we need to do is plug these values in to our expression here. So now this is going to be equal to K2. So we got K2 here, 7.2 times 10 to the negative 2, and that's going to be 1 over molar seconds. So 1 over molar seconds, so that's going to be multiplied by our square root of K1. K1 is 5.0 times 10 to the third. So 5.0 times 10 to the third. And it's going to be 1 over seconds. Let me write this better. Okay, and that's going to be 1 over, or that's going to be to the 1/2 power. Oops, I forgot my 1 over seconds. So 1 over seconds. That's going to be to the 1/2 power because that's the same as the square root. Okay, and then we're going to divide this by the square root of K minus 1. And K minus 1 is 3.0 times 10 to the 5th. So 3.0 times 10 to the 5th. And again, that's going to be 1 over molar seconds. And that's going to be to the 1/2. Okay, so now what we can do is we can multiply and divide. Okay, so let's start with the numbers because that's going to be easier, and then we'll figure out what how the units cancel out. So if we take the numbers, right, and multiply and divide, we get 9.3 times 10 to the negative 3. So KO is equal to 9.3 times 10 to the negative 3. Now we just have to figure out the units, right? So let's take the units and figure that out. So here, I'll do it on this side. So I'll just take the units. So we have 1 over, let's see where I have space. Yeah, I have space here. So I have 1 over molar seconds, 1 over molar seconds times, and I have 1 over seconds to the 1/2. Okay, so let's go ahead and do the square root. So square root 1 over seconds. I'll show you why I'm doing that in a moment. And then we're going to divide this by the square root of 1 over molar seconds. So 1 over molar seconds square root. Oops. Let me find space here. Okay, I'll do it up here. We have space up here. So I'm going to take this again. Sorry about that. So I have 1 over molar seconds multiplied by the square root of 1 over seconds over the square root of 1 over molar seconds. So what we can do is kind of separate everything out. So just to make it clear, so up here I can separate that out and say 1 over molar times 1 over seconds, right? And then multiply that by the square root of 1 over seconds. Bear with me. And now I can do the same thing on the bottom. So here I have the square root of 1 over molar seconds. That's the same as the square root of 1 over molar times the square root of 1 over seconds. So right away we can see things cancel out. So square root of 1 over seconds will cancel out with square root of 1 over seconds on the top and bottom, right? Okay, so far so good. So now we have 1 over molar times 1 over seconds over this. Now, one thing you can do is multiply the top and bottom by the square root of 1 over molar, right, to kind of get this to the top here, right? So if I multiply the top and bottom by this denominator in the square root form, so we get square root of 1 molar over or under the square root of 1 over molar. Okay, so far so good. So now look what happens. I have this times this gives me what, right? It gives me, if I multiply the square root of 1 over m times the square root of 1 over m, I get 1 over m, right? So now what I have is, if I write it down here, if I continue this down here, I have 1 over m times 1 over s times 1, the square root of 1 over m, all over. Now I have square root of 1 over m times the square root of 1 over m. Well, that gives me 1 over m. So now I have 1 over m. Look here, I have 1 over m, 1 over m. Now that can cancel out. Now I have, look here, so this is going to be equal to 1 over seconds times the square root of 1 over m. Well, what is that? That's just the same as, that's equal to 1 over seconds times 1 over the square root of molarity. And again, we can rewrite the square root of molarity as 1/2, right? So now we can write the units of KO. So here, the units of KO to our answer is going to be molarity to the 1/2, but if we bring that up, this is the same one. I'll write it again. This is going to be the same as molar to the negative 1/2, right? Because I bring this up, I change the power, the sign of the power, so this becomes molar to the 1/2, and then 1 over S is the same as S to the negative 1. So now I have my KO with the proper number of units. And that, ladies and gentlemen, is how you do it. I know this is a longer video, but I think it's worth to go over step by step to really make it clear how you find the answer. And I hope this was helpful. I hope you enjoyed the video. I hope you stayed for the whole thing. And if you did, kudos to you. Let me know what you think. Do me a favor, hit that like button down there somewhere. Hit that like button, share the video. Also, make sure that you subscribe to my channel. Help me out here. Hit that notification bell up there. When you do, click all, so that way you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or question you need help with, or if you have a topic you would like me to cover, write that down below. I would love to do that for you. Thank you so much. Have a great day.